All right. So next part, we are going to be doing stoichiometry. Um, let's see. So when you see the molar ratio between lithium fluoride and aluminum fluoride, that is just talking about the coefficients, right? So here are all of our coefficients. There's nothing there, so that means 1, right? And so if we want, we can even get rid of that and know that it's 1. But those coefficients, and why balanced equation is so important in chemistry, is that it allows us to connect substances to one another, right? For every 6 lithium fluoride is what this is saying. We have 2 aluminum fluoride, right? 6 here, 2 there, and that helps us. Now, yes, it is technically a 3-to-1 ratio. I suggest just keeping it that way. The math works out anyway, but keep it this way just as not to confuse yourself, because this 3 is here as well, and you don't want to think when I write a 3 and a 1 that I'm talking about lithium sulfate and aluminum sulfate there. So keep it as is. In our stoichiometry, remember, there's grams of substance A and moles of substance A to moles of substance B to grams of substance B, or even sometimes to liters of substance B, using our 22.4 liters equals 1 mole conversion here. Of course, every mass, right? Every mass to mole here to here has to use the molar mass from the periodic table. So this one's molar mass. This is molar mass here as well. And then, of course, this is the coefficients that we just talked about for the ratio, the mole ratio there from the balanced equation. So that's how you go from one thing to another, and based on how many arrows or how many bridges you cross, remember we had our mole bridge, that's going to tell you how many steps you need to take. Like for this problem right here, I needed 2 bridges to be crossed, so I had to have 2 steps, right? And over here we can start looking at what we need for each of these. So how many moles, so we're looking for moles, are used to produce this many moles of lithium sulfate. So we are going from mole of A to mole of B, and that's just one step, which is nice. So that's 25.2 moles of our lithium sulfate is going to go here, moles of lithium sulfate to moles of aluminum fluoride, and we use our balanced equation here. So lithium sulfate I see has a coefficient of 3, so it's 3 of these for every 2 of these, and now we go to work, and your answer should be 16.8 moles of aluminum fluoride. Now, what you could do to make this a little bit easier on yourself is when you're going through these, you can simplify the top by multiplying them together, and then simplify the bottom by multiplying them together, whatever it is, right? This is just an imaginary 1 there, so 1 times 3. But if there were more steps, you can just multiply the bottom together too, and you have this nice little just one number over the other to calculate this if you don't want to put it all in your calculator at once. Anytime you see grams, this tells you immediately to find the molar mass of whatever comes after, whatever the substance is. In this case, that's lithium fluoride, and the molar mass we've done already, but this one should be 25.94 grams per mole. And so anytime I have grams, I immediately want to grab my periodic table, calculate the molar mass, because that's going to give me the grams, the mass that's equal to 1 mole to use as a conversion factor. So in this case, I want liters, right? So what we're doing in step by step is we're starting with grams of A, and I know this is A and this is B because they're 2 different substances. I always start with A, I always end with B. We're going grams, and before we do anything, we have to get to moles. That's our bridge to get to our other substance, and then we are going to end in liters of B, all right? So this is 1, 2, 3 steps, all right, that we're going to take. So I'm going to start with my grams of lithium fluoride. I know that there are 25.94 grams of lithium fluoride for every 1 mole of it. All right, the only time we have numbers in front of our mole unit here that are not 1 is this step right here, because that's where I'm actually going from moles of A, right, to moles of B. That's this step here. So I'll leave that highlighted so you can kind of see that. And then we're going to aluminum fluoride, which is AlF3, and that is going to give us a 6:2 ratio, again, from our balanced equation. And now after that step, whenever we have mole, we are going to put 1 again. And this time I'm going to liters, so I don't need the mass of aluminum fluoride because it's not asking me for that. Don't do more than you need to. Tip. And we end up with, if you do the math, 0.72 liters of aluminum fluoride there. All right. How many grams? So immediately I see grams of lithium sulfate. Well, I know that lithium sulfate is Li2SO4. And so I have to find the molar mass of that to use it as a conversion. And that is, I think, 109.95 grams per mole. And then are produced from this many grams of lithium fluoride. And lithium fluoride, again, is LiF. Since it's grams, I know I need to use the molar mass that we had calculated from above. We've already used that substance before. And now this is a grams of A to moles of A to moles of B to grams of B problem, right? And I know that based on what I'm starting with and what I want to end with here. So I am going to use what I'm given at first, 23.1 grams of lithium fluoride. All right, and then I convert that to moles first. All right, that's my first step. So that's 25.94 grams of lithium fluoride equal to 1 mole of lithium fluoride. And here's that step where I now hop from one thing to another, moles of that to moles of lithium sulfate. And I know that in my balanced equation, I had a 6:3 ratio between those two substances. And then I go from moles of lithium sulfate to grams of lithium sulfate, which in this case, I now use the molar mass of that substance B. And that is going to get me a value of 48.96 grams of lithium sulfate there. All right. And last but not least, we had a lot of questions on how to do these particular problems again. So in this case, you see that you are starting with 2 different amounts of things. And now think of it like what we talked about before is, say you have, and I'm going to erase this, but say you have 8 hot dogs and 12 buns, right? Well, an equation, if we wanted to, is 1 hot dog plus 1 bun gives us a 1 hot dog bun, hot dog with bun, right? So we have to figure out, okay, based on that recipe, right? Well, what is going to run out first? And obviously, you see, since it's 1-to-1, these hot dogs are going to run out first. And once I run out of hot dogs, I can no longer make any full, complete hot dogs with buns, right? So that's what we would call our limiting reactant, right? Because out of the things that we're starting with, which are reactants, that is going to limit the amount of hot dogs I can make. I can only make a maximum of 8 hot dogs, even though if I just looked at the 12 buns, that would tell me that I could potentially make 12 hot dogs. But that would then have us consider, this as the excess reactant. So this is the kind of a very general way to think about this. But if I go through and I try to set this up, what we're doing is we're trying to figure out how many grams of substance B here we would get if we started with substance A, we'll say A1, and then substance A2, right? So we're going grams to grams for both of these problems. The only difference here is, and how about I use a different color for B here? The only difference is now we're going to be doing it twice to compare answers, right? So for the first one, and I see grams, so I'm going to do make sure that I have, LIF is my 25.94 grams per mole. I know that aluminum sulfate, Al2SO4, a little obnoxious to write, but it's okay. That one is, I believe, 342.17 grams per mole. Oh my goodness. And then, of course, because I want grams of aluminum fluoride in the end, I know that aluminum fluoride has a mass of 83.98 grams per mole. So I have all my molar masses, which are going to allow me to go from moles to grams of each of these things. And now let's go to work. So 3.5 grams of lithium fluoride. I'm going to convert that to moles so that I can get to my destination substance, which is aluminum fluoride there. There's LIF. And I know that for every 6 moles of lithium fluoride I have, and again, we're using a balance equation from above. It's the same exact substances that we've been using. What is that? 2 moles of aluminum fluoride. And then we keep it going. That's going to be a little obnoxious if I immediately change it to red. So how about we wait for that? Let's just kind of keep it as is so it's not too many colors. So 2 moles of aluminum fluoride. And I want grams in the end. That's what I'm comparing. You could stop at moles too because you get the same idea. But because we're going to want the amount of the aluminum fluoride produced in grams, we'll just go all the way. So eliminate something that we'll have to do in the end. So moles of aluminum fluoride there. And that is 83.98 grams of aluminum fluoride. So if I do the math here, this tells me that I should be able to produce 3.78 grams of aluminum fluoride. Now we do the exact same thing. The only difference is we start with our other reactant amount, which is that many grams of the aluminum sulfate, right? So we do the same steps, 342.17 grams of aluminum sulfate is going to be equal to 1 mole of aluminum sulfate. And then our step here, going from one to the other, 1 mole of aluminum sulfate, glad I don't have to write that one again, is equal to 2 moles of aluminum fluoride. And what you'll notice is when you get to this step right here, these are going to be, this is exactly the same step for both of these because we're trying to get to the same spot. We're just starting with 2 different things. 83.98 grams of aluminum fluoride here. And then we go and we calculate, and that is 2.75 grams of aluminum fluoride. So now you look and you have 2 different amounts that are produced. And obviously you can't have 2 different amounts of the same thing. So we got to pick one, right? And what ends up happening is we look and see, well, just like our hot dog example, which one is going to produce the least amount? Because once I produce that amount, that means that is it. I run out of that particular substance that I started with in order to make that. So we look at both of these and we see that this right here is our, and actually now I'll use the red. So this is going to be the amount of product that we actually produce. So for the amount of aluminum fluoride produced, it's the least, or the lesser amount that you calculated, right? And that would be 2.75 grams of aluminum fluoride there. Right? And so effectively we can just get rid of the other one, right? Because we can't make that much. In theory, we would be able to if this is the only value that we had to work off of. But because we know how much of the other reactant we have, now we know that we wouldn't be able to make 3.78 grams of this product. We would only be able to make this and stop. So what happens now? Well, whichever one produces the lesser amount is the limiting. So you could say the limiting reactant produces the lesser amount, and that's because it you could say it limits the reaction, right? It limits the amount that you're able to make. And that's why we call it the limiting reactant. And when we're talking about a reactant, you're talking about these two things that you started with over here. So what are they? Well, the limiting in this case is the aluminum sulfate, and the excess ends up being the other one, which is the lithium fluoride, right? So there's no numbers there. I know some of us like to take these two things and subtract. You're not doing any of that. You're just taking and looking at these two things and saying, hey, well, this limited the reaction. I'll do it in the red just so that it's popping. But this is the limiting reactant here, which means this is the excess, right? I have more left over that, but it has nothing to react with because our limiting got used up. All right, so that's our Stoich unit. Hopefully this helps, and I'll see you in a couple of future videos.